Hey Simon, can you hear me? Hey Simon. Hey Simon, can you hear me? Hey Simon. Hey Simon, can you hear me? Hey Simon. Hey Simon, can you hear me? Hey Simon.
Yes, I can hear you. All good. We'll start in about like 5 minutes.
Hey Simon, can you hear me? Hey Simon.
Namaste and good afternoon, everyone. I'm Upiksha Tiladar from Bugolmi, joining from Nepal. It's my pleasure to welcome you all to the very first episode of Era of AI, a live research webinar series where we highlight the latest work in artificial intelligence from people actually building it. This series was created to spark meaningful conversations around real world AI systems, not just the breakthroughs in labs, but the technologies being deployed in healthcare, public policy, education, business, and beyond. Every episode will feature one presenter diving into their research, framed by a quick roundup of week's most exciting AI news, followed by live Q&A where you can engage directly. This is our experiment in making AI research more open, more relatable, and more relevant. We are so excited to kick this off today with our pilot episode. Now, let me quickly walk you through this agenda. We'll begin with a short This Week in AI segment featuring our moderator Simon Dhungana and co-host Sara sharing fresh insights on what's new and noteworthy across the AI landscape. That will lead in today's main presentation by Shon Mohsin, who will be walking us through DemographDB on a novel AI system designed to predict adverse health outcomes using demographic and clinical signals. It's a powerful example of how machine learning and graph-based models can intersect to improve public health outcomes. After that, we'll open up the floor for a Q&A, so be sure to note your questions throughout the session. We'll then wrap up with a few closing remarks and a preview of what's coming in future episodes. Now, before we begin, you'll see few profile slides introducing our amazing speakers. You'll hear more about them shortly, but I want to say how grateful we are to have such a thoughtful and experienced panel today. Let me introduce to the panel Son T. Mohsin. He is a proud father of two, a loving husband, and someone who enjoys playing guitar and listening to all kinds of music. Professionally, Sean is an experienced IT leader and data scientist with over a decade of work designing and delivering enterprise scale systems for Fortune 500 companies and government agencies. At CVS Health, he leads the SMS Vervia's experimentation team, where his work with Azure Data Lake, Spice Spark Pipeline, and Zen AI driven in intent model has improved prescription pickup significantly. Before this, he contributed to ML forecasting and graph database initiatives at Heart Health and worked on large-scale Medicaid and SaaS transformation for the Department of Veterans Affairs, Virginia Medicaid, and Molina Healthcare. He is currently completing his Doctor of Engineering in AI at George Washington University and holds a master's in data science and a bachelor in clinical psychology. Uh, Sara is an AI researcher with a passion for building ethical human-centered AI system with experience training multimodal models and leading cross-functional data projects. She brings a grounded practical perspective to today's rapidly evolving AI landscape. Currently pursuing a doctorate in artificial intelligence and machine learning, Sara explores the intersections of bias, language, and vision in modern AI systems. Uh, Simon Dhungana. Simon is a senior leader in technology and business development with a strong track record of delivering innovative, AI-driven solutions across global teams. He has led major initiatives that bring together data science, engineering, and product strategy, including platforms like globalpack.com, which has reached over 1 lakh users, is widely used for election forecasting and survey research. Simon has also built high performing project management offices and used AI to boost operational efficiency with deep expertise in Agile and Scrum. He has accelerated federal technology bids and driven successful outcomes. These days, he is focused on launching fast moving AI proofs of concept and helping organizations quickly turn their ideas into reality. With that, I'll now hand it over to our moderator, Simon Dhungana, to get us started with the latest from the world of AI. Simon, over to you. Thank you and good luck. Simon, you are on mute.
Oh my goodness. Okay. All right. Here we go again. So I'm excited about this inaugural session. We have a very knowledgeable and experienced professional giving us a presentation on demograph. We'll hear all about it. Prior to that, we'll talk a little about what's been going on, in the field of AI for the last week or month. Me and Sarah, I'm glad I have Sarah join us here for this co-hosting of this program. So the way, as Upeksha explained, the way we'll do is like, we'll talk a little bit about what's been going on in primarily five different fields, like, what's in the AI in workplace, AI in healthcare, and five thematic different aspects. And from there, we'll, jump into Sean's presentation. And depending on the questions and answers we get, we might, just like, nudge Sean to answer right there, or we'll, wait till the end to do a Q&A for about anywhere from 30 to 45 minutes. We'll be hearing from Sean on that. So with that, I am very excited and welcome.
Thank you.
Yeah, this is so this is a good experience for us, all of us, So I am going to start with the first slide that I have here and just set the stage, and we'll take it from there. So I wanted to, so a few of the things that we are talking about today is like, first of all, we'll talk about the AI in the workplace. We'll talk about frontier AI models. That's all the rage now, especially with the new AI action plan released by White House yesterday. And then we'll talk about AI-powered discovery, and then we'll talk about healthcare AI. So, and then responsible AI, obviously, you cannot leave anything without being responsible with AI. So the first thing I want to talk about is, AI in workplace, just like, just to kick things off, even a few years ago, right? AI tools or assistants, now they're like autonomous contributors from like email writing and all that, just depending on the level of usage people have. So this is something that's slowly taking more and more of our workload. Some of the leading examples like, Auto GPT, Devin, Google Seeds, these help us every day to automate our business workflows. Some of us that inclined on the background of it, how it works, it has a hierarchical reinforcement learning, memory graphs, and program synthesis. So this is the impact on one of the section we have here is like, what does it have on the impact of jobs? Everyone's talking about the impact of jobs, right? So we all remember back in early 1900s when they introduced tractors in the working fields in farms. People thought that was going to completely, that would essentially replace all the farm workers. But what that ended up doing was like it did replace farm workers who did not use the machine. So it's a good apt analogy, I think. So these are some of the impacts that's going to have on this. Like it will probably replace some entry level, data entry, but it'll augment knowledge workers, and it'll probably spawn a new AI oversight integration role. So yeah, Sarah. So what do you think about some of the frontier models that's coming out?
Yeah, so let's talk about the new wave of frontier AI models, because honestly, it feels like we're in the middle of a transformation that feels like science fiction is like catching up to us, right? So the New York City Times recently ran the headline for some recent graduates, the AI job apocalypse may already be here. And that does sound a bit dramatic, but also it's not wrong, right?
Yeah.
We're seeing systems like GPT-5, Gemini 2, Claude 3, GPT-4o, and these are operating across text, vision, audio, like you name it. And they're not just faster or more accurate, they're reasoning across these modalities. So they're doing things like summarizing long documents, analyzing video, writing code, and even responding in real time. Now, under the hood, it's tech like transformers, mixture of experts, and multimodal learning that's powering the sleep, right? And these aren't just fancy buzzwords. These systems are actively solving the problem of like fragmented data. So yeah, here's the twist though, like they're reshaping work, which means that analysts, content writers, and even junior developers, these roles are being augmented or automated. And yeah, so it's not about what AI can do anymore. It's about how fast the workplace is changing because of it.
Absolutely. And anyone who doesn't use it, it gets left behind. So one of the things that I think we have a recurring theme is like, this having to learn constantly on a daily basis, almost like what's out there, what's coming up, right? So, and acquaint ourselves with that. So, this is going to hit us close to home. AI in research labs. AI is revolutionizing how we generate and test scientific hypotheses, right? So tools like AlphaFold, IBM Discovery Studio, and open source graph neural networks. I think the graph part of that, we might hear a little bit more from Shon about that, is being used to predict protein finding, suggest new drugs. And these are going to impact on our longevity in our healthcare down the road also, right? So what's really exciting here is the shift from the wet lab to the code lab, right? So we can now imagine all of these things. And it's also typically, a generative model can reduce a 6-month screening process to 6 hours. So these are big, big deals. So, and the underlying technology on this is like, the Bayesian optimization, a probabilistic way to balance the exploration with and exploitation and graphical neural networks, right? So these are also, these model the molecules or experiments as connected networks of influence. So they will help prior to actually doing a test. So these are AI is really accelerating, not just, it's not just acceleration, it's also an augmentation, I would say, right? So AI is now a thought partner in a scientific explorations. So that's something that is going to be very interesting as we go forward. So, the healthcare AI, Sara, is another of this innovation, right?
Right. And this is where AI is quietly making some of the biggest real world impact. The Washington Post ran a headline saying why your job may face a double threat if the economy sours. And so in regards to this, systems like Watson X, MedGemini, In Silico, etc., they're being used for everything from automated like charting to early diagnosis and even drug discovery. And this isn't theoretical anymore. It's live in hospitals and labs right now. And on the tech side, tools like self-supervised learning and federated models are enabling patient data to be used responsibly without violating privacy, which is critical in a field where compliance is everything, right? So these advances are tackling real pain points, physician burnout, diagnostic delays, medical errors. AI is stepping in to do the grunt work, which are like routine diagnostics, admin tasks, so clinicians can focus more on patients. And again, this shift is creating new kinds of jobs, like healthcare data scientists, AI clinical trainers, and digital diagnostics specialists. So whether you're in tech, healthcare, or policy, this isn't a side story, right, anymore. It's the main narrative of how AI is starting to reshape the systems that shape us.
Absolutely. And I want to quickly also point out, right? So the data, one of the biggest concerns that folks have is like, about healthcare data is like, are they protected? Are their healthcare data protected? So the HIPAA, the Health Insurance Portability Act that was passed in early 1990s, it has this 18 fields that has to be masked, that has to be de-identified. So there are certain safeguards, and European Union, EU also has like GDPR, so these data policies and all that. So that definitely is going to help progress on this while keeping the patient data and confidentiality also safe. Talking about confidentiality, we have we've been hearing about a lot of manipulating AI and how do we build an ethical AI system, right? So this is something I know human-based system that you built, you are working on, Sara. This is something that you've also done, right? So, but we the thinking is, right, we need to have an AI that is responsible, that is trustworthy, that is ethical, right? So, I mean, the recent headline on Washington Post that says like Americans worry AI is coming for these jobs, right? And a Pew Research survey shows that Americans and experts agree on some jobs that they think will be most affected by artificial intelligence. But regardless of what these jobs are overtaken, how they are overtaken, the underlying fact is like the system needs to be trustworthy and ethical. So some of the things that can make it happen is through, adversarial testing, explainable AI. We know how Shat can explain which features it will actually has made a larger impact in that AI decision. So the other thing is like, instead of having a black box of this dense neural network, now we are talking about having some sort of a glass box that people can see through it, finagling with a little bit of wets and biases and stuff like that. So this essentially solves risks from biased, unsafe, opaque AI systems. So we want AI to essentially be able to, when it makes a decision, when it makes a prediction, for us human to be able to know, okay, this is exactly why it made that decision, so that we can tweak it, we can, do that. So this is, I would think this is one of the things that also was talked about in the action plan that the White House released yesterday, was like, building an ethical, trustworthy system. And so instead of focusing just on the narrative that's being fed by certain things, we want to have this wholesome knowledge base that's out there. So with that, wonderful talking about this, and we'll head on to the next part of our webinar and go to the main show, a presentation by Shon. Again, I want to I can't stress enough how lucky we are to have Shon present us in this. This is phenomenal. The thing he's going to be talking about is phenomenal. It's not just, it touches all of our lives. You're talking about, democratizing AI, making it accessible, making it like, touching lives of folks that are not, easily, those are not touched, and the high prices, everything. So he's going to talk a lot about that. So glad to have Shon, and also, and then we'll Shon, if you don't mind, we might jump in with some questions. So we might just wait till the end. With that, Shon, I will hand the floor to you. Sara, do you want to add something before we hand over to Shon?
Maybe just one quick note, because I know a lot of the headlines that we've been seeing today has been very like doom and gloom, and especially for the entry level new graduates that are coming in. And I just want to say, like, there is an opportunity when you're entering the workforce at exactly the right time to learn with these tools instead of fighting them. I feel like students who understand AI workflows, data ethics, and how to communicate with or customize models are going to have a real advantage. So the future doesn't just belong to coders or creatives anymore. It belongs to people that can collaborate with AI across disciplines.
Absolutely, absolutely. And I think it's worth pointing out that, especially you're talking about junior high school students, that they still need to focus on STEM. That's not going away. The mathematical foundation is not going away. You have to learn those, right? Yeah. So, and the models behind it, so that you can, yeah, sure, LLMs and Gen AI can help in a lot of stuff, but, it's for us to accept and adopt to this changing landscape and excel in it. So instead of being afraid of it, as you rightly pointed out, once we embrace it, I think we got ways to go. Thank you so much for that quick pointer.
Critical thinking will never go away.
Absolutely. That's what makes us sentient human beings, right? So, all right, Shon, off to you.
Yeah, thank you so much. I think, so before I get into the presentation, I want to touch on a couple of things you guys talked about. What's really interesting is we do have all of this gloom and doom, but I myself am a futurist. So okay, I'm not looking at the next 10 years, I'm looking at the next million years and where we're going, right? And so from that perspective, all of these are welcome changes because the net benefit usually outweighs the net risk. But one thing I will say is, when I was starting out in my career, I had a manager that told me, don't come to me with problems, come to me with solutions, right? And so what does that mean today? That means use everything in your power to solve a problem. At the end of the day, AI is an interface, right? It doesn't have, even agents don't have agents, right? Only people have agents. So if you can figure out a way to solve a problem, that's the only skill set you need to survive for the next 50 years. Solve problems. That's it. Doesn't matter how, as long as you do.
Absolutely. That reminded me. I was in one of the conferences in GW quite some time back, and there was this professor was saying, like, how does she use AI and all the implications of using AI, especially in academic field. So she was talking about the sandwich model, right? So AI is the meat. So you start off with your own thinking, what you want to do, right? And then use AI, that meat part, to kind of elaborate on that. And then at the end, again, you have the next slice of bread that you come up and you finalize. So that's, I think, that goes along the way of what you're thinking. And I'm glad to know we have a futurist here. So yeah, Shon, what do you think, Sarah?
So let me jump into the problem that I'm trying to solve. And I love graph databases, so I'll show you my T-shirt. Right, I'm wearing a T-shirt that says, "I hate to brag, but I like to model."
Hang on a second. Let me spotlight for everyone. Could you step back again, please? All right, we can see it a little bit now better. Yeah. Okay.
So even before this push into AI, I've always been interested in how humans learn, right? How do we process information? It's quite different from how machines process information. Machines process information in rows and columns, but humans always process information via semantic meaning and establishing connections of previous pieces of information that we know about. And that's how our brains work, right? Our brains are giant graph knowledge models, right? And so it's really natural to kind of think of information. If you can translate tabular information into knowledge graphs, it transforms the way you can interact with the information, because now you're establishing these fundamental connections between pieces of data within the data set itself. And that provides a lot more power, and that's what I'll go into. But this problem that I'm trying to solve is, in healthcare, you go into, let's say, the doctor's office or the emergency room, right? And the doctor pulls up your information and they see your patient records, okay, you're 40 years old, you're male, you're female, whatever that information is. But that's not your universe of information. There's so much more information about you: what your diet is, where you live, the pollution levels, the quality of the water, the neighborhood you're in, your income levels. All of these things affect your health in imperceptible but actual ways, right? So these things are affecting your health, whether it's elevating or depressing your mood, whether your environment is safe or dangerous, whether the pollution levels or the amount of plastics that you consume, whether you eat from a ceramic bowl or a metal bowl, right? All of these things over time affect the expression of your final health outcome that you went to the doctor to see. But the doctor doesn't know any of this. So they can only diagnose observable symptoms. And I say observable, obviously there's a lot of ways to diagnose you, but there's all of these other factors that clinicians can't account for. And so that's where I want to solve that specific problem. Is what about all of this other information? Is there power underneath it? Are there connections between all of these pieces of information and this final expression of health outcome that you're now here to mitigate? And so that's where DemographDB comes in. So I'll start.
It reminds me almost like Shon. I mean, like I'm not trying to be too simplistic. Nature and nurture, right? So that what makes us a human. It's not just what's coded in our DNA that can be discerned or deciphered by a system, but also the subtleties of everyday societal lives that we go through, right? So you're thinking of a wholesome system that the doctors will be able to understand and perhaps diagnose you better.
Yeah, absolutely. I'll give you a really interesting piece of information. There was a study done a while ago that showed a correlation between your height and whether you had diarrhea in the first year of your life.
Mm-hmm.
So it's a simple thing like that, right? So if the food you ate in the first year of life had some contaminants that gave you diarrhea, you would never reach your full potential, right? You take that same kid and you give that kid clean food in the first year of life, they'll probably be 2 to 3 inches taller, right? So think about that. So, and I'm from a third world country, and I was born there. If I went to the doctor,
I think the new term is global south.
Sure, I gotta update my terms, but think of that piece of information. A doctor could never know that kind of information, but if you carried it with you somehow, right? Even if it was an aggregated statistical form, it could give power to your current diagnosis, right? So those are the kinds of interesting things that are possible when you have the universe of information about a patient, not just their clinical data. All right, so I'm gonna share my screen. Now I can't find the share button. Hold on. Sorry, is it enabled? Simon, do you want to present? Because I don't see the share button here.
Give me a second. Let me see if I can have you. Okay. Yeah, we can see you now.
Okay. So the thing I'm working on is DemographDB. This is a real world application. I think by the time I'm done fully proving out the model, someone could take this, put it into production, and gain more meaningful insights into the patients that come in. Obviously, I being a single individual can't optimize for all of the different targets, right? And so I've gone with, the most drastic target, which is whether you died or not from a visit to the ER, right? But fundamentally, you can shift the target from that specific label to any other label to give you information about a person as you encounter them. So let's talk about GraphDB. So first I'll talk about GraphDB and its capabilities, and then I'll talk about the importance of mortality prediction.
So did you coin this term, DemographDB, Shon?
Yes, that's
awesome. Awesome.
Yeah. How knowledge graphs can play an important role in creating outcomes and inferences that you can apply to patients. So let's talk about the background. So our knowledge graphs, right? Knowledge graphs stem from a mathematical subfield called graph theory. And graph theory didn't receive a lot of attention until, let's say, the 1940s and beyond. But before that, one of the first written expressions of graph theory was Euler's bridge problem. So in Königsberg, in Königsberg, Germany, there's a piece of land that's surrounded by 7 bridges, right? And you see the island in the center. And he was wondering, is there an optimal way to traverse these bridges only once to get to the other side, right? Can you traverse these bridges only once to get to the other side? So that was the first theoretical application of trying to solve a real world problem using knowledge graphs. So we didn't call those knowledge graphs back then. So this was just a graph theory problem. So why use knowledge graphs? There's a lot of benefits. One of the biggest benefits is you directly establish a semantic relationship between entity A and entity B, right? So between Simon and Sara, here are 2 entities, they're people, but you can establish a link that says co-hosts, right? Here's an additional piece of information that if you put it on a tabular database, you wouldn't be able to discern, right? You would need an additional field, co-host. But here, you're doing it explicitly. And so if you think about the larger picture, what you're doing is establishing kind of a semantic connection, right? So you can think of it as a sentence now. There's a meaningful, there's an explicit meaning between the connection, but there's also latent meaning because the connections are not random, they're intentional. And so when you apply intentionality to data, and then you extract latent information, that latent information has power. And that's really the shift from tabular data sets to these knowledge graphs is there's additional latent information that you and I may not be able to see, but advanced neural networks can extract.
And we're talking about thousands and millions of dimensions, right? What kind of dimensions are we talking about?
Yeah, we're talking, so my graph network has 9 million nodes.
Wow.
The scale is large, and one of the cool things about knowledge graphs is you can take, with some minimal processing, you can apply and you can add different sets of information, right, from all different sources into a knowledge graph to create a unified data structure, which is very hard to do in a traditional relational database. You'd have to match columns, you have to have key IDs, you'd have to ensure atomicity. All of these restrictions are removed, and now it's much easier to connect disparate data sets if you know what to connect them on. It's really minimal processing. And so using knowledge graphs really, for large organizations, it opens up a new way of looking at your information. Right now, data is power. But almost all organizations that you go to, large organizations, they don't know how to use their data effectively. And so this is the key. If you can create meaningful relationships between your data sets, now you can ask questions of it. So that's another really important thing that knowledge graphs do. So back to my problem. So healthcare data is hard to get, right? Privacy restrictions, all of that. It's really hard to study, but the Healthcare Cost and Utilization Project is a government and private partnership where you can apply for a research license, and if you do, you have access to actual patient records, which is really important. If you're trying to do healthcare, you need actual patients. Synthetic data does not work. Synthetic data destroys the underlying power in your data sets, no matter how carefully you synthesize that data. And so real data is a challenge that most people face when trying to solve healthcare data set problems. And so the HCUP is a really good resource. And then, so that's my healthcare data set. And then the ACS is the American Community Survey. So I'm sure you've seen this. The census data, you might have gotten a mailer in your
Once a decade, right?
Yeah, it's once every 5 years.
5 years, okay.
Statistically, they have it so that you're not. Yeah, it's aggregated once a decade, but every 5 years, you probably get a survey. So that's how they do the spread of the entire United States. So the ACS is a really good source of demographics information, and it's geospatial, right? The demographics information is geospatial, so it's tied to an area. And that's a really key piece that we'll talk about. So what is my thesis? My thesis is that if you combine deep learning with social determinants of health and healthcare data, that can enhance your downstream prediction models. It'll enhance the accuracy of these prediction models because now it has additional latent information that it did not have before. And so one is a private data set. So for a company, their private data set. And the second is a public data set. There's many different data sets you can download depending on your use case. But the hard part is connecting data sets. It's not about getting them, it's about connecting them. And so the knowledge graph is the vehicle through which you can connect these data sets. And so that's a demonstration here is how do I connect survey data to healthcare data, right? And the way I've done it is I know that if you live somewhere, the statistics of that neighborhood is going to affect you in some way. So for me, the connection is the geospatial location. So your FIPS code. So if I have your FIPS code and I can connect the statistical data for that FIPS code to you, now when I run all of the information for you through a model, I have additional information that may enhance the prediction that I can give to you. So that's the key here. And so the first question I try to answer is, if I put healthcare data into a knowledge graph, does it work? Right? That's the baseline hypothesis. I did a linear regression and I saw, yes, this data set has power to predict 82%, right? If I put it in a knowledge graph, is it more than random? That's all I want to know is it more than random? And then if it is, then I know that that theory works. And then I want to add the survey data, ACS data, and then I want to see, does it increase it from that baseline? And then if it does, then I want to employ really advanced techniques. The latest structures for embedding is the STAIR algorithm. That's one of the latest pieces of research. And so if I use STAIR and then I run it through a transformer, is the output better than what I got for linear regression? And so if I can prove those three things, then really this model and this framework has widespread applicability in healthcare and many other industries. So this is my architecture. I won't dwell on this too much, but what I want to emphasize is the knowledge graph and how it's structured and how you've created it is not that important. What's important is that neural networks need vectors to process data. So if you can transform your knowledge graph into an embedding, you can feed that embedding into a transformer model, into any downstream neural network model to get your predictions without having to do laborious data transformations. So no feature engineering needed, no transformations needed, no one-hot encoding needed. None of that is needed because you're taking your knowledge graph and you're applying an embedding algorithm, and boom, you've got your embedding. It's normalized, it's tabular, it ranges from 0 to 1. It's absolutely ready for you to feed into your transformer. So it simplifies this enormous data processing challenge that you had to have before into just a simple embedding. And you take the embedding and then you train your downstream model. So really, it's a framework more than anything else.
Okay, but the challenge, I think you'll still have some challenges with the data standardization, right?
No,
No?
that's the point, right? The point is, how can I make this as easy as possible to get disparate pieces of data? So there are some best practices for how you transform data to go into a knowledge graph. But once you've done that, and you've established your semantic connections between your entities, that's the end of the processing.
Okay.
So I have a question. So then that must mean that it's that much more crucial to have very clean data coming in, right? To have like complete clean
With
data.
scale, it doesn't matter. If you can get a large enough data set, the bigger your data set is, the less you have to clean, because your incorrect data is less statistically significant to the underlying embedding. And so, obviously you're going to have your margin of errors for the inference, but scale defeats data cleaning.
Okay. Interesting.
Yeah.
Yeah, this is like, I was thinking about this, and this could have a larger implication or ramification for other areas as well, the way you're doing this.
Yes. So the applicability is really anybody that needs answers and has dirty data. That's the customer base essentially for this solution is, do you have dirty data? Do you have it in different places in different formats? Do you want answers out of your data? So that's pretty much the entire world. I'm focused on healthcare because my background is in healthcare. I've been in the healthcare industry for 15 years. But essentially, you establish your graph database and your knowledge graph, right? And then the methods is, we talked about this briefly. You join your ACS to your HCUP data, different algorithms like note to vec and stare embeddings. So the key point is, I want to get the embedding out of the knowledge graph, right? I don't care what the knowledge graph looks like. All I care about is the output, which is the embedding. Now, in between, you have some model that takes this information and turns it into an embedding. So those are replaceable components. So first I use a note to vec, I take that out, then I use a stare, I take that out, and then you can put anything else. But the output is the embedding. Once you have the embedding, then you can put it into a transformer. Maybe tomorrow they'll embed something even better, and you can use that. So this is really modularized in terms of application. So, you analyze the data, and so my data set is about 2 million records. I don't need to balance the data set, again, because all I care about is the embedding and putting that into a transformer. So no need to balance the data set. I focused on the dyed column because that's a pretty easy binary column to create inferences on. But if you needed a probability range, you can select a different target. So I did the baseline using logistic regression. I got about an 82.4. And so my goal is to beat this. So currently I'm working on setting up the pipelines for my note to vec and stare. I already have my knowledge graph created, and hopefully in the next month or two, I should have really interesting results, and maybe I can come back out and show them to folks.
Awesome. Awesome. So many things was like swirling my mind, essentially. Like what you're doing, this is like, so one of the things that concerns me is like how this system, let's say you build a system, how affordable would this system be? How would it be available to people everywhere?
So for sure, I'm building a SaaS company after this. So
okay,
I'll sell it to you.
Yeah. So, but it'll probably come up with some hefty price. What I'm trying to say is like, um, this can obviously folks who healthcare always has been that way, right? So when the penicillin was, discovered back in Western Europe, folks who could afford it basically started getting antibiotics. But it wasn't until almost like 75, 80 years later that it became available for the masses, that people could actually live, even if they were infected with all these biologics. So in that sense, do you have any thoughts on how this might, be more available widespread?
So yeah, I'll talk about the applicability of this technology. So the first, and there's use cases in healthcare, and then there's use cases really anywhere else, right? The first use cases in healthcare is, so healthcare has a couple of different entities, right? You have your frontline doctors, you have your hospitals, and then you have your insurance companies, right? So I've worked in the back end, so not in hospitals and not for doctors, but I've worked for insurance companies. And so this application is really like, my first thought is like, how can an insurance company use this? And today, every single insurance company, when you sign up, they look at your information to assign you a risk score between 0 and 1. If you have a risk score of 0, that means you will not use any services for the upcoming year. If you have a risk score of 1, that means you use 100% of the allocated services. And if you have anything more than that, that means you 2 times, 3 times as much cost. So the way it works is about 80% of the people don't use healthcare services at all. Most people are healthy, but the 20% that do, they make up for the entire cost of the healthcare. And so if you can more accurately assign scores to your patient population, then you can more accurately predict what your upcoming year's costs will be. And this is really important because the way insurance companies work that administer Medicare and Medicaid is they say, okay, here's 100 people, and I'm going to charge $1,000 to service these 100 people. And I know that 80 people will have $0, and the rest of them will have $800, so I can keep $200 in my pocket, right? So that estimate, when you provide to the government, that's what they pay you. Now, if you spend over, that's out of your pocket as an insurance company. And if you spend under, then you have to give money back until you get to that 80%. So that 80% threshold is constant as a contract, but if you go above your 80%, you eat that loss as an insurance company. So it is in your best interest to always have the most accurate information about your patient roster. And so this is a really good way to assign a risk score because they're already doing it. They're already using machine learning and various methods, statistical analysis, time series analysis to apply. But now with this, you're incorporating various other pieces of information that you're not to increase the latent information that you use to process your inference.
Very cool. I actually have a question for you, Shon. So you mentioned that knowledge graphs introduce context, structure, things like that, and the output of your architecture is going to be an embedding. Have you considered looking at how bias may be encoded in those embeddings? Because in the research that I've done, I've seen that there may be bias that are within the embeddings themselves. I mean, our society is biased, so we can't help but to have those things. So is that something that you've considered within your own research?
It's a good question. So from a purely implementation perspective, you should put in unbiased data sets into your knowledge graph. So that's a pre-processing step, okay? Now, from an ethical,
There is some pre-processing being done here.
well, if your data set is biased, then you can't use it for anything, because whatever downstream application you have is going to incorporate that bias, right?
Right.
So that's really a data collection and data pre-processing, and really an ethical consideration. Now,
Right.
the truth is, when we say bias, right, bias is subjective. So what you and I think is a bias may not be a bias to somebody else, right? So these are ethical conversations that need to be had. They're not implementation conversations. Of course, you want to eliminate bias, but I always start by saying, what is the definition, right? Where is the binary of bias versus non-bias? If it's a sliding gray window, which it always is, right? What are your thresholds? How do you reject or accept a record based on the heuristic that you've defined? And so these are kind of outside the scope of what this implementation is, but the truth is, bias is a human invented term, right? And so the definition of bias varies from person to person. If there was a standard, table of biases and thresholds, then everybody would use that table to process their records, but there isn't. So it really depends on, at the point of data collection, whether you're accounting for the biases that you've determined with your peers is a bias, and then if the data is already collected, if you have internal processes to understand and refine them. I know that's not a good answer, but it's a realistic answer, at least from my experience.
Yeah, so that kind of had me thinking again. So another job that AI is going to create is I know a lot of big companies already have it, but once Shon hits NASDAQ, he'll probably need to hire a chief AI ethics officer as well, right? So or AI ethics lead. So this has to be, like you said, a part of the conversation from the get-go on AI first strategy. You can't just rely on this thinking everything's going to be good, because everything has not been good in our history of humankind. So we have not necessarily been nice to each other. We have not necessarily been objective, even when we say we are. So I think that's an awesome. So every company will have an AI ethics officer now. So that's good. So I have looks like this.
I think so. I do have to drop, but I will leave you with this, right?
Yeah.
So there's a 6 printed on the floor, and there's a person on this side and a person on this side. One person points and says 6, and the other person points and says 9. Who's correct, right? And so that's the fundamental problem with bias is there's no universal agreement. Of course, there's egregious stuff that you can really quickly define, but the nuance is where you need philosophers, right? You need a philosopher. So the philosophy degree is going to become really important, I think, in the future for understanding and solving these crucial human issues when we get to our next era of AI.
Okay, I think there's a last question, Sarah. If you can paraphrase that, would appreciate it. There's a QA.
Let me see. Okay, so there's a question that says, how might integration of real-time data, examples are EMR streaming, wearable health monitors, reshape the value proposition of knowledge graphs and mortality prediction? Shon, I think that's for you.
Yeah, so it's quite easy to integrate as long as you set up the pipeline to feed in the data. The hard part is updating your embedding, right? So you have to choose a cycle. Do you want to do it, every 30 minutes? Do you want to do it every day? Obviously, the shorter your time frames, the more costly it'll be to update your embedding. So there are a lot of business and cost decisions to your update frequency, and it depends on how crucial the outcome will be. If you're in a high stakes real time environment like the emergency room, it might be worth it to bear the cost. If you're using it for predicting once a year forecasts, not so much. It depends on the business context.
Absolutely. So yeah, with the rapid development of all these physical devices, that's absolutely critical, right? So yeah. So yeah, Sarah.
Yeah, I think, Sean, you made a good point. There is definitely not just one way to measure bias, right? So far, there hasn't been a standardized way. So that is something to look for in the future, is to kind of work together. We are empowered to make these changes ourselves, right? So yeah, in closing, thank you so much for presenting DemographDB. This was very eye-opening in what is possible in this field.
Absolutely. Thank you so much, Sean. And I think this inaugural session has been very productive. This is, I think, the value of this type of webinars. There has not been enough. You see some of these AI related programs, webinars cater to our general population using AI tools and all that. But what about for like an academicians? What about like researchers who can actually gain from this, right? So by putting this on YouTube and stuff like that, I think researchers all over the country, globally, in fact, universities, colleges, and all, they can listen in on Sean and listen in on our conversation and perhaps garner something from it, get something out of it, and hopefully that'll be useful in advancing the field and technology of AI. And with that, I again want to thank you, Sean, and thank you, Sarah, for joining me in this journey. It's been amazing. It's very insightful, very invigorating, all excited. And thank you so much. And with that, I bid adieu to everyone watching this live and participating in Zoom. See you.